January 1941. The Impossible Promise. San Diego, California. Consolidated Aircraft Corporation's B-24 Liberator production facility. Charles Cast Iron Charlie Sorensen, Ford Motor Company's production chief and the man who had transformed Henry Ford's vision of the moving assembly line into reality, walked through Consolidated's sprawling outdoor assembly area with growing disbelief. B-24 bombers sat scattered across the tarmac in various states of completion. Wings were assembled in one area, fuselages in another, tail sections somewhere else entirely. Engines hung from improvised wooden rigs. Workers moved components using cranes, trucks, and sheer muscle power. The entire operation looked less like modern manufacturing and more like medieval craftsmen building cathedrals. Painstaking, labor-intensive, impossibly slow. Consolidated was producing approximately one B-24 per day using these methods, 30 aircraft monthly from their San Diego facility. For peacetime production, this was adequate. For the war everyone knew was coming, it was catastrophically insufficient. The Army Air Forces projected needing hundreds of B-24s monthly within 2 years. That night in his hotel room, Sorensen sketched a radical alternative vision on hotel stationery. Break the bomber into sub-assemblies, build components in parallel, move everything on synchronized assembly lines, bring the work to the workers rather than workers to the work. Apply the same mass production principles Ford had pioneered with automobiles to the most complex aircraft America had ever attempted to build. The next morning, Sorensen told Consolidated executives and Army officials that Ford Motor Company would build B-24s, not components, complete aircraft, using assembly line techniques. Ford would construct the world's largest factory specifically for bomber production. The facility would produce one 4-engine heavy bomber every hour. Every hour. 24 per day. Over 600 per month. The claim seemed preposterous. Aircraft weren't automobiles. They required precision tolerances measured in thousandths of an inch. They contained over 1.5 million individual parts compared to a few thousand in a car. They needed constant engineering modifications as combat experience revealed design flaws. The very concept of mass-producing heavy bombers defied conventional wisdom about aircraft manufacturing. Consolidated's executives smiled politely at the brash Ford production man making impossible promises. Army officials were skeptical, but desperate enough to consider anything that might increase bomber production. Henry Ford, 83 years old and officially retired but still dominating company decisions, made the final commitment. "We have never made an airplane, but we can make anything." Within weeks, construction began on what would become Willow Run, the single largest manufacturing facility ever built, the embodiment of American industrial might, and proof that Sorensen's impossible promise was actually conservative. At peak production in 1944, Willow Run would complete one B-24 Liberator every 63 minutes. The site Henry Ford selected for his bomber plant was farmland he personally owned near Willow Run Creek in Washtenaw County, Michigan, approximately 30 miles west of Detroit. The rural location seemed odd for the world's most ambitious industrial project. Why build far from Detroit's established infrastructure, skilled workforce, and support industries? Ford's reasoning was characteristically practical and autocratic. The government wanted to finance the project. Ford refused government money, insisting his company would build the facility and sell it to the government, which would then lease it back to Ford for the duration. This arrangement kept government bureaucrats out of construction decisions. Building on Ford-owned land eliminated land acquisition complications and legal challenges that might delay construction. The Willow Run site also offered space, vast, flat acreage where Ford's architects could build a factory whose scale would dwarf anything previously attempted. Architect Albert Kahn, who had designed most of Ford's existing facilities, created plans for a structure so massive it redefined industrial architecture. The main factory building would measure 1 mile long,
5,280 feet of continuous production space with an L-shaped layout featuring a distinctive 90-degree turn. The turn served dual purposes, keeping the entire facility within one county to reduce tax complications and avoiding encroachment on the airport Ford would build adjacent to the factory. Total factory space, 3.5 million square feet under a single roof. More floor space than 62.5 football fields. The main assembly hall alone could fit the Pentagon inside with room to spare. Supporting structures brought total building space to over 7 million square feet. The complex included die shops producing over 30,000 dies and special tools, heat treating facilities, foundries casting engine components, machine shops with over 8,000 machine tools, storage warehouses, administrative buildings, and 1,484-acre airport with 6 runways, aircraft hangars that could shelter 20 B-24s simultaneously. Worker housing developments. Construction began March 1, 1941, 9 months before Pearl Harbor. 5 main contractors worked simultaneously on different sections. Workers used plywood partitions to seal finished portions from areas still under construction, allowing equipment installation and production startup before the building was complete. The scale challenged construction techniques. The roof alone required over 5 million square feet of material. Heating and cooling a space this vast demanded innovative climate control systems. Lighting the interior, natural light couldn't penetrate deep into the building's interior, required thousands of fixtures drawing megawatts of power. Cost, $47 million, equivalent to approximately $900 million today. An additional $200 million for tooling, dies, jigs, and specialized equipment. The facility's sheer size became both asset and liability. The 1-mile assembly line allowed unprecedented workflow efficiency, but the distance from one end to the other created logistics nightmares. Managers needed bicycles or motorcycles to travel between production areas. Material handling required sophisticated conveyor systems. Communication relied on newly installed telephone networks and public address systems that still left sections of the plant effectively isolated. Charles Lindbergh, serving as a consultant, called it the Grand Canyon of the modern world. Reporters dubbed it Willow Run, but also Willie's Run, and less flattering nicknames like Will It Run, reflecting skepticism about whether such an ambitious project could succeed. German intelligence, monitoring American industrial expansion through aerial reconnaissance and human intelligence sources, cataloged Willow Run's construction with growing alarm. Abwehr reports to Berlin documented the facility's extraordinary scale but struggled to explain its purpose. What could possibly require a factory this large? The concept of mass-producing 4-engine heavy bombers seemed so implausible that some German analysts speculated Willow Run might be an elaborate deception, a massive decoy facility designed to draw German bombing attempts that would never reach across the Atlantic. They would learn the truth soon enough. The first B-24 components rolled through Willow Run's gates in September 1941. 3 months before Pearl Harbor brought America into the war. The plant was partially complete, still under construction in multiple sections, staffed by workers who had never built aircraft, using processes that existed only in Charles Sorensen's mind and on engineering drawings. The initial results were disastrous. Ford had originally contracted to build B-24 components for final assembly at Consolidated's Fort Worth plant, or Douglas Aircraft's Tulsa facility. But Sorensen convinced the Army to let Ford build complete aircraft at Willow Run, a decision made before the plant had produced a single component, let alone a finished bomber. Everything that could go wrong did. Blueprint problem. Consolidated's design documentation was incomplete and often contradictory. Drawings were hand-sketched rather than mechanically drafted. Tolerances were vague, many components weren't fully specified. Consolidated's craftsmen built parts by eye through experience, rather than precise specifications. Ford engineers had to reverse engineer thousands of components, measuring parts from existing B-24s and creating proper engineering drawings before production could begin. Design changes. Consolidated and the Army Air Forces continuously modified the B-24 based on combat experience from Europe. Changes that made sense for improving aircraft survivability created havoc on assembly lines designed for standardization. A modification to engine mounts might require retooling hundreds of production fixtures. Changes to electrical systems could affect dozens of subassemblies. Quality control. Early B-24s leaving Willow Run had quality problems that were frankly embarrassing. Rivets weren't properly set, electrical connections failed, hydraulic systems leaked, fuel tanks didn't seal correctly. The Army Air Forces initially refused to accept Willow Run-built bombers for combat operations, relegating them to training duties while Sorensen's team worked frantically to identify and fix quality issues. Worker training. The workforce grew from 5,000 in early 1941 to over 42,000 by 1943, but most had never worked in aircraft manufacturing. They were automotive workers, farmers, housewives, students. Ford established an aircraft apprentice school that trained up to 8,000 students per week. But converting automotive assembly skills to aircraft precision manufacturing required time and painful learning curves measured in defective parts and rejected assemblies. Labor relations. Henry Ford's violent opposition to unions had created bitter labor relations across Ford facilities. In April 1941, just as Willow Run ramped up, the UAW called a massive strike at Ford's River Rouge plant. Although Willow Run wasn't directly affected, the strike created tensions that poisoned workforce morale. Ford's initial refusal to hire women workers, he considered factory work unsuitable for women, created additional labor shortages that persisted until he reluctantly relented in 1942. The first complete B-24 finally emerged from Willow Run on May 15, 1942. Serial number 42-7770, a B-24E-1-FO designation indicating Ford-built Liberator. It had taken 160 days from America's entry into the war to produce one airplane. At this rate, Sorensen's promise of one bomber per hour seemed laughable. Critics dubbed Willow Run "Will It Run" and questioned whether Ford's automotive expertise translated to aircraft at all. Senator Harry S. Truman, heading the Senate Special Committee investigating defense production waste, visited Willow Run in April 1942. He left deeply skeptical that the massive investment would pay off. His committee's reports questioned whether the government should continue supporting such an expensive, trouble-plagued program. German intelligence, monitoring American production through various sources, noted Willow Run's slow startup with satisfaction. Their analyses concluded that American attempts to mass-produce heavy bombers had failed. The facility might eventually contribute to Allied bomber production, but it would never achieve the scale American propaganda claimed. By late 1942, Willow Run had produced only 56 B-24s, less than 2 aircraft per week. Sorensen's promise of one per hour looked like typical American bluster. The bomber gap remained firmly in Germany's favor. Then, everything changed.
The breakthrough came not from a single innovation, but from hundreds of small improvements implemented simultaneously as Ford's team learned to manufacture aircraft at automotive scale. Standardization. Ford engineers finally completed proper documentation for every B-24 component. Precision jigs and fixtures ensured parts were identical. Workers no longer had to hand-fit components. Parts simply snapped together because tolerances were controlled from the first production step. Sub-assembly synchronization. The key insight was breaking the B-24 into major sub-assemblies that moved through the plant on parallel paths.
Nose section, forward fuselage with bombardier station and nose gun. Cockpit section, pilot and co-pilot positions, flight controls. Bomb bay section, central fuselage with bomb racks and fuel tanks. Waist section, gunner positions and defensive armament. Tail section, rear fuselage and tail guns. Wings, left and right wings built separately with engines pre-installed. Tail surfaces, vertical stabilizer and horizontal stabilizers. Each subassembly moved on its own line, built by specialized teams using dedicated tools and fixtures. The sections converged at carefully choreographed junction points where they were joined, tested, and moved forward on the main assembly line. The mile-long line stretched 1 mile from initial subassembly to finished aircraft. Bombers moved continuously through stations where workers performed specific tasks. Station 1 to 20, initial fuselage assembly. Station 21 to 40, engine installation and wing attachment. Station 41 to 60, tail assembly and control surface installation. Station 61 to 80, electrical system installation and testing. Station 81 to 100, hydraulics, fuel system, defensive armament. Station 101 to 120, interior equipment, instruments, radios. Station 121 to 140, final assembly and quality inspection. Station 141 to 152, paint, final systems testing, and acceptance. The line moved approximately 100 feet per hour. A B-24 started as separate components at Station 1 and emerged as a fully functional 4-engine heavy bomber at Station 152 roughly 24 hours later. Quality improvements. As workers gained experience, quality improved dramatically. Willow Run built B-24s went from barely acceptable to among the best-built Liberators produced by any manufacturer. The 8th Air Force in England, initially skeptical of Ford-built bombers, began specifically requesting Willow Run aircraft because they had fewer mechanical problems than B-24s from other plants. Workforce optimization. By 1943, Willow Run employed 42,000 workers on 2 9-hour shifts 6 days per week. Women comprised over 40% of the workforce. Rosie the Riveters, who had initially been excluded by Henry Ford's prejudices, but proved essential to achieving production targets. Roswell Monroe, a riveter at Willow Run, became one of the models for the famous Rosie the Riveter imagery, though multiple women have claimed that distinction. The numbers told the story of transformation. 1942, 56 B-24s produced, total year. January 1943, 31 B-24s produced. March 1943, 75 B-24s produced. June 1943, 190 B-24s produced. September 1943, 365 B-24s produced. December 1943, 428 B-24s produced. By the end of 1943, Willow Run was producing more B-24s monthly than all other manufacturers combined.
April 1944. Willow Run hit its stride. That month, workers in 2 9-hour shifts, working 6 days a week, produced 453 B-24 Liberators in 468 hours of operation, an average production rate of 1 complete 4-engine heavy bomber every 63 minutes. 63 minutes, just over 1 hour from raw materials and subassemblies entering the line to a fully functional bomber rolling out onto the runway. Charles Sorensen's original promise had been 1 bomber per hour. Critics had mocked it as typical American exaggeration. Sorensen had delivered. To understand the magnitude of this achievement, consider what a B-24 Liberator actually was. Physical specifications. Length, 67 feet, 2 inches. Wingspan, 110 feet. Height, 18 feet. Empty weight, 36,500 pounds. Maximum takeoff weight, 65,000 pounds. Complexity, over 1.5 million individual parts. 30,000 rivets in the fuselage alone. 4 Pratt & Whitney R1830 engines, 1,200 horsepower each. 10 .5 caliber machine guns. Bomb load capacity, 8,000 pounds. Maximum range, 2,100 miles. Crew, 10 men. Every 63 minutes, Willow Run workers assembled 1.5 million parts into a functioning war machine capable of flying across the Atlantic, bombing German industrial targets, and defending itself against fighter attack. The statistics from April 1944. 453 B-24s produced in 30 days. 15.1 bombers daily. 1 bomber every 1.58 hours or 95 minutes. Peak efficiency, 1 bomber every 63 minutes. At this production rate, Willow Run was completing B-24s faster than German factories could produce all types of aircraft combined. In April 1944, German industry produced approximately 2,200 aircraft of all types: fighters, bombers, transports, trainers. Willow Run alone produced 453 4-engine heavy bombers while also supplying knockdown kits for assembly at other plants. German intelligence, finally comprehending the scale of Willow Run's output through reconnaissance photographs and intercepted production reports, struggled to credit the numbers. 1 bomber every 63 minutes seemed physically impossible. Surely American propaganda was exaggerating. Surely the photographs showed the same aircraft photographed repeatedly to create illusions of mass production. But Luftwaffe pilots flying over Germany saw the truth. American heavy bomber formations, hundreds of B-17s and B-24s darkened the skies daily. Where were they all coming from? How could America sustain such losses, bombers shot down by the dozens daily, and return with even larger formations days later? The answer was Willow Run and facilities like it. America was building bombers faster than Germany could destroy them. The production race was over. Germany had lost before most German generals understood a race was occurring. Sadly, one of the people most responsible for Willow Run's success never saw the triumphant April 1944 production numbers. Edsel Ford, Henry Ford's only son, president of Ford Motor Company, and the executive who championed the B-24 project despite his father's initial skepticism, died on May 26, 1943, at age 49. The official cause was stomach cancer, but those close to Edsel understood that stress had accelerated his decline. Managing Willow Run while simultaneously managing his aging, increasingly erratic father had created pressures that would break most people. Henry Ford, 80 years old in 1943, remained nominally retired but constantly interfered in company operations. He opposed Edsel's decisions publicly, undermined his authority with subordinates, and second-guessed strategic choices. The Willow Run project, Edsel's vision supported by Sorensen, but initially questioned by Henry, became a focal point for father-son tensions that had simmered for decades. The production problems of 1942-43 intensified the stress. Every setback, every quality issue, every delayed delivery gave Henry Ford ammunition to question whether Edsel had led the company into an expensive failure. The Senate investigation added public scrutiny. Labor conflicts at other Ford facilities spilled into Willow Run. And through it all, Edsel worked punishing hours, trying to make his father's company deliver on promises Sorensen had made. When Edsel died in May 1943, Willow Run was finally approaching consistent production, but hadn't yet achieved the breakthrough that would come in 1944. He never saw his vision fully realized. He never knew that Willow Run would ultimately produce 8,685 B-24s and knockdown kits for another 1,893, nearly half of all Liberators built during the war. Charles Sorensen, writing years later, stated bluntly, Edsel Ford's death was hastened by the strain of Willow Run. He believed in the project when others doubted. He fought for it inside the company and outside. The stress killed him before he could see success. Henry Ford, devastated by his son's death, briefly resumed the company presidency, a disaster that nearly destroyed Ford Motor Company. At 80, his mental faculties were failing. He made erratic decisions, fired capable executives, and might have destroyed the company if Edsel's widow hadn't intervened. Henry Ford II, Edsel's son, took control in 1945 and saved both the company and Willow Run's remaining production runs. The personal tragedy of Edsel Ford's death reminds us that behind industrial statistics and production numbers were human beings working under extraordinary pressure, making decisions that affected national survival, and sometimes paying ultimate prices for their dedication.
Production at Willow Run continued at high rates through 1944 and into early 1945. Monthly output fluctuated based on material availability, design changes, and strategic priorities, but generally remained above 400 bombers monthly through the end of 1944. Production by year: 1942, 56 B-24s. 1943, 2,476 B-24s. 1944, 4,536 B-24s. 1945, 1,617 B-24s. Production ended June 1945. Total: 8,685 complete B-24 Liberators, plus knockdown kits for another 1,893 aircraft assembled at other facilities. Willow Run's output represented approximately 47% of all B-24s produced during World War II. The plant built more B-24s than Consolidated Aircraft, the design originator, produced at all its facilities combined. Peak monthly production: 453 B-24s in April 1944, though some sources cite slightly higher numbers in other months depending on how partial assemblies and kit shipments are counted. The last B-24 built at Willow Run was serial number 44-51928, a B-24 M30-FO that rolled off the line on June 28, 1945. The aircraft was flown directly to a storage facility and later moved to the Reconstruction Finance Corporation site at Kingman, Arizona, where it was scrapped. One of thousands of bombers that never saw combat because the war ended before they were needed. Production ceased officially on May 31, 1945, when Germany's surrender made further B-24 production unnecessary. The Pacific War continued, but the B-29 Superfortress had taken over long-range bombing missions. The B-24, despite its significant contributions, was already obsolete. Willow Run's total war contribution: 8,685 complete B-24 Liberator bombers, 1,893 knockdown kits for assembly elsewhere, engines, components, and spare parts for thousands more aircraft, employment for 42,000 workers at peak, over $3 billion in military production value. The facility demonstrated conclusively that mass production techniques pioneered for automobiles could be adapted to the most complex military equipment. The lessons learned at Willow Run influenced post-war aircraft manufacturing, missile production, and eventually spacecraft assembly. The strategic impact: bombing Germany into defeat. The B-24s built at Willow Run didn't win the war alone, but they were instrumental in achieving strategic bombing campaigns that systematically destroyed German industrial capacity and broke the Wehrmacht's ability to sustain military operations. B-24 Liberators flew with both the 8th and 15th Air Forces in Europe, conducting daylight precision bombing raids against German aircraft factories, oil refineries and synthetic fuel plants, transportation networks and marshalling yards, U-boat construction facilities, ball bearing plants, chemical works. The famous raid on Ploiești oil fields in Romania on August 1, 1943, was flown entirely by B-24s. 178 Liberators attacked the refineries, producing one-third of Germany's fuel supply. The raid achieved strategic results despite heavy losses. 54 aircraft shot down, 532 aircrew killed or captured. Many of those B-24s were Willow Run built. B-24s also served crucial roles in the Pacific, flying long-range missions against Japanese targets from bases in China, India, and island chains across the Pacific. The Liberators' extended range, longer than the B-17 Flying Fortress, made it ideal for Pacific operations where targets were separated by thousands of miles of ocean. German war production statistics reveal the impact. By 1944, Allied strategic bombing had reduced German production capacity by approximately 30 to 40% compared to projected output without bombing. Fuel production dropped catastrophically from 316,000 tons monthly in early 1944 to under 20,000 tons monthly by September 1944. The Luftwaffe was grounded for lack of aviation fuel. Panzer divisions sat immobilized for lack of diesel. German industry struggled to maintain even minimal production under relentless bombardment. B-24s from Willow Run, identifiable by their FO production code, participated in all major bombing campaigns. They flew through flak so thick, pilots described it as if you could walk on it. They faced Me-262 jet fighters that no bomber formation could evade. They endured sub-zero temperatures at 25,000 feet in unpressurized cabins. Casualties among B-24 crews were horrific. Roughly 25% of air crews flying European missions became casualties. But the bombers kept coming. Every bomber shot down over Germany was replaced within days by fresh aircraft from Willow Run and other factories. German fighters would intercept a formation, shoot down a dozen B-24s at the cost of several fighters, and watch in dismay as even larger formations appeared the next day. The production capacity Willow Run represented, the ability to sustain losses and continue operations through overwhelming material superiority, proved as decisive as any weapon technology or tactical innovation either side deployed.
When B-24 production ended in June 1945, Willow Run faced an uncertain future. The facility had been built for a single purpose: producing bombers for a war that was now ending. What do you do with 3.5 million square feet of factory space designed specifically for aircraft assembly? Initially, the government sold the plant to Kaiser Frazer Corporation, an automotive manufacturer hoping to establish itself in the post-war car market. Kaiser Frazer used Willow Run to build civilian automobiles from 1945 to 1953, though the company never achieved financial stability and eventually ceased operations. General Motors purchased the facility in 1953 and used portions for automotive transmission production. The plant was dramatically less active than during wartime, a few thousand workers rather than 42,000, producing transmissions rather than complete aircraft. Over subsequent decades, ownership changed multiple times as different companies used sections of the massive complex for various manufacturing purposes. But the glory days, the epic scale of bomber production that had amazed the world, never returned. By the 2000s, most of the original Willow Run complex had been demolished. Automotive companies had moved to more modern facilities. The land was more valuable for redevelopment than for maintaining outdated industrial structures. Only a small portion survived, the section where finished B-24s rolled out onto the runway. The Yankee Air Museum, recognizing the historical significance, fought to preserve this segment as a museum dedicated to Willow Run's legacy. Fundraising, historical preservation efforts, and community support saved the building from complete demolition. Today, the Yankee Air Museum at Willow Run stands as a monument to American industrial achievement. Visitors can walk the same floor where 8,685 bombers once stood before flying off to war. Interpretive exhibits explain the assembly process, commemorate the workers, and preserve the memory of when this corner of Michigan was the center of global industrial warfare. Tragically, no B-24 Liberator remains at Willow Run. Of 18,482 B-24s built by all manufacturers, only a handful survive in museums worldwide. None are available for display at the facility that built nearly half of them. The museum displays photographs, production equipment, and worker testimonials. But the bombers themselves, the fruits of all that labor, all that innovation, all that sacrifice, were mostly scrapped after the war, cut apart for aluminum to be recycled into peacetime products.
Willow Run succeeded because it applied automotive mass production principles to military equipment that conventional wisdom insisted couldn't be mass-produced. Charles Sorensen's vision, breaking complex assemblies into synchronized sub-assemblies moved on coordinated production lines, transformed aircraft manufacturing from craftwork to industrial process. The facility demonstrated that American industrial capacity, properly organized and sufficiently motivated, could achieve production scales that seemed impossible. One 4-engine bomber every 63 minutes wasn't miracle, it was engineering, logistics, and workforce training applied systematically to eliminate every inefficiency. German intelligence officers who initially dismissed Willow Run as propaganda eventually had to confront reality. American industry was producing war materiel at rates Germany simply couldn't match. No amount of engineering sophistication in German weapons design could overcome American advantages in mass production capability. The lessons from Willow Run extended far beyond World War II. Complex equipment can be mass-produced if designs are properly standardized. Workforce training matters more than workers' prior experience. Breaking complex assemblies into synchronized sub-assemblies enables unprecedented production rates. And industrial capacity determines strategic outcomes in total war. Modern aerospace companies still study Willow Run when designing production facilities. Boeing's 737 assembly line in Renton, Washington, producing one aircraft every 2 to 3 days, uses principles pioneered at Willow Run. Airbus's A320 production system similarly relies on subassembly synchronization that Sorensen perfected in 1943. But perhaps Willow Run's most important legacy is simpler. It proved Henry Ford's characteristically arrogant claim correct. We have never made an airplane, but we can make anything. They could. And they did. One bomber every 63 minutes. 8,685 B-24 Liberators rolled off Willow Run's mile-long assembly line and flew off to war. Nearly half of all Liberators built. Aircraft that bombed German factories, attacked Japanese shipping, and helped win the war through industrial capacity that enemies couldn't match. German spy officers photographed Willow Run from across the street. German-American Bund members and Abwehr agents documenting the facility's construction and operation. They sent reports to Berlin describing the unprecedented scale. Some German intelligence officers dismissed the reports as exaggerations. Others struggled to comprehend what American industry was achieving. They didn't want to believe one bomber every 63 minutes. The concept violated everything traditional aircraft manufacturing taught. But the evidence was undeniable. Reconnaissance photographs showing hundreds of B-24s parked at Willow Run's airfield production schedules captured through espionage, and, most convincingly, the endless formations of liberators bombing Germany daily. By the time German leadership fully understood what Willow Run represented, it was far too late. The industrial race was over. America had won through production capacity that seemed impossible until cast-iron Charles Sorensen made it reality. The mile-long assembly line, the 42,000 workers, the 3.5 million square feet of factory floor, 8,685 four-engine bombers in less than 4 years. One bomber every 63 minutes. Will it run? It ran. It ran faster and more efficiently than anyone except Charles Sorensen believed possible. And in running, it helped win the war.
In memory of the 42,000 workers who built bombers at Willow Run, the air crews who flew them into combat, and Edsel Ford, who died before seeing his vision fully realized, their collective effort proved that American industrial capacity, properly organized and motivated, could achieve production that enemies considered impossible.